Hi everyone. In this video, we'll go through a few problems related to transformation formulae. Let's take this particular problem where we have to prove that cos 2a minus cos 12a by sin 12a minus sin 2a is minus tan 7a. Now, before we get into solving these problems, let's look at the formulas. Here's a list of transformation formulas, right? So let's look at these formulas. Now, these are the formulas where we have addition of trigonometric angles expressed as product of trigonometric functions. When you're adding sin C and sin D or subtracting sin C and sin D, then you'll have to use sin and cos, right? You'll have to use sin and cos. Since when it is plus sign, it'll be sin and cos. When it is minus sign, that is when there is a difference, you'll have to use cos and sin. You'll have to reverse this. Now, similarly, if you're adding two cos angles, cos C and cos D, in that case, you'll have to use cos. You'll have to use cos for both the functions, cos C plus D by 2 into cos C minus D by 2. Now, if it is plus, you'll have cos. If it is minus, you'll use sin here. You'll use sin with negative sign, minus 2, right? Using these formulas, let's solve the problems. So here we have cos 2a minus cos 12a, right? So this is nothing but the fourth formula, if you remember. So when there is cos and minus, it's a fourth formula. When you have cos and minus, you have cos and you have minus. So it's a fourth formula, which is minus 2 sin C plus D by 2 into sin C minus D by 2. And here you have sine angles, sin 12a and sin 2a with minus sign. That is we are finding difference. So this is second formula, right? This is fourth formula. This is second formula. So sin C minus sin D is 2 cos C plus D by 2 into sin C minus D by 2. Here we have first term related to cos and second term is related to sin. So now substituting, this becomes C, right? This is our C and this is D. This is C and this is D. So C plus D, 2a plus 12a by 2, 2a minus 12a by 2. That is C minus D by 2 and C plus D by 2. Similarly here also, C plus D by 2 and C minus D by 2. Now using these formulas, you will see that 2 and 2 will get cancelled. Sin 5a and sin 5a will get cancelled. Left with sin 7a by cos 7a, which is nothing but minus tan 7a. Sin by cos is tan. So minus tan 7a, which is equal to RHS. So these are the formulas that we have used here. Cos C minus cos D and sin C minus sin D. Now let's go to the second problem. Here we have to prove that sin x minus sin y by sin x plus sin y is equal to tan x minus 1 by 2 into cot x plus y by 2. Now first let's figure out the formulas to be used. Here it is sin x minus sin y. So remember that order, right? First let's remember the order of the formulas. First formula is sin C plus sin D. Second formula is sin C minus sin D. Third is cos C plus cos D. Fourth is cos C minus cos D. Now let's remember this order, right? Now sin x minus sin y, this is second formula, right? This is second formula. In second formula, what you're going to have, here you have sin on both the sides, right? So it's going to be sin cos. It'll be a combination of sin cos like this. It will be sin cos, but since it is minus sign here, right? Since it is minus sign here, we will reverse. It will be cos C plus D by 2 into sin C minus D by 2. For sin x plus y, what formula will use? Sin x plus sin y will use sin C plus sin D. That is the first formula, right? What is the first formula? It is sin and cos, right? So the moment we have sin, we are adding sin angles or subtracting two sin angles. In that case, we'll have to use sin cos, right? But here sin will come in the first, cos will come in the second because it's addition here. Here it was subtraction, so it will be swapped. It will be cos first and sin second. So we'll use this formula. So it is C plus D by 2, right? This is C, this is like D, this is C and D. So instead of C we have X, instead of D we have Y. So X plus Y by 2 and it is C minus D by 2, right? This is C minus D by 2. So X minus Y by 2. We'll substitute all of this. 2 and 2 will get cancelled and we'll be left with what is cos x plus y by sin x plus y? Cot x plus y by 2. Cos by sin is cot. Sin by cos is tan. Tan x minus 1 by 2, which is equal to RHS, right? This is what we have to prove. This is our RHS. So we have proven this particular expression. Now let's go to the third problem. Similar to the second one, we have to prove that sin 2 alpha plus sin 3 alpha by cos 2 alpha minus cos 3 alpha is cot of alpha by 2. Right? Now, let's first figure out the formula. This is sine and sine. Sine and sine is first formula because there is positive sign, plus sign. So first formula. First formula is sine cos combination, right? Sine cos combination, right? This is the formula. Sine and cos. Sine c plus d by 2 into cos c minus d by 2. And here you have cos 2 alpha minus cos d alpha. So this is fourth formula. This is first formula. This is fourth formula, right? Remember, fourth formula will have minus 2. It is having negative sign, so it will be sine and sine, right? Sine and sine. So we are using, for this one we are using cos c minus cos d. Cos c minus cos d is minus 2 sine c plus d by 2 into sine c minus d by 2. It is sine, just observe, right? Whenever you have cos, right, be it cos c plus cos d or cos c minus cos d, you will have same terms here. When it is cos c plus cos d, you will have cos c plus d by 2 into cos c minus d by 2. Basically both will be cos and cos. But cos c minus cos d is sine. Minus 2 sine c plus d by 2 into sine c minus d by 2. Now we'll substitute all of this. 2 alpha plus 3 alpha by 2. It's going to become 5 alpha by 2. And here it's going to be 2 alpha minus 3 alpha, which is minus alpha by 2. Now this will get cancelled here. You're left with cos by sine. Cos by sine is cot of minus alpha by 2. And you already have minus here. This minus is because of this minus 2. So it's going to become minus cot of minus alpha by 2. Now you can bring this minus outside. So it's going to become cot alpha by 2, which is equal to RHS. Now before we go to the fourth problem, let's once again look at these formulas, right? We can actually look at these formulas and try to visualize a lot of things, right? So again, I will reiterate the formulas. When you have sine C and sine D, that is, you are adding two sine angles, right? And there is plus sign in between, it should be sine cos. And here it is difference, right? Difference of sine C and sine D. Both are sine here. So you'll have same sine cos, but it will be reverse. And when you have cos and cos combination, right? Third and fourth formula, cos and cos form combination. When there is plus sign, it will be cos and cos. When it is minus sign, it's going to be sine and sine. And the last formula will always have minus. So remember this. So now let's go to the fourth problem. Sine pi by 3 plus a minus sine pi by 3 minus a is equal to sine a. Now pi is 180 degree, right? Pi is 180 degree. So pi by 3 would be 60 degree. Now this is of the form sine C minus sine D, right? You can consider this entire thing as C and this entire thing as D. So sine C minus sine D. What is sine C minus sine D? Immediately, this is the second formula in the list. Second formula is with sine cos combination. But since it is minus, it will be cos first and sine second, right? Now we'll substitute all of this. You will see that a and a will get cancelled. We'll be left with 2 pi by 3. 2 pi by 3 by 2. 2 and 2 will get cancelled. And here also pi by 3 and pi by 3 will get cancelled. You're left with 2a. 2a by 2. 2a by 2. 2 and 2 will get cancelled. So we're left with 2 cos pi by 3 into sine a, right? Pi by 3 is 180 by 3, which is 60. Cos 60 is half. So 2 into half into sine a. 2 and 2 will get cancelled. So you're left with sine a, which is equal to RHS. Now let's go to the fifth problem. Here you have cos a plus cos 120 minus a plus cos 120 plus a is equal to 0. So let's take this entire thing as LHS, right? This entire thing is LHS and this 0 is RHS, right? We'll start with LHS. There are two ways to solve this problem. You can directly use compound angle formula. That is cos 120 minus a, you can use cos a minus b formula, right? Cos a minus b is cos a cos b plus sine a into sine b. This is cos a minus b formula. Here we can use cos a minus b formula. Here we can use cos a plus b formula. Cos a plus b is cos a into cos b minus sine a into sine b, right? Now you can see I've used method 2 here using compound angle formula. Now you have substituted a compound angle formulas, right? And you'll see that two terms will get cancelled. You're left with cos 120 cos a, cos 120 cos a, which is 2 cos 120 into cos a. And then you have cos a here, right? We have three terms, 1, 2, 3. What is cos 120? So here's the calculation for cos 120. How will we calculate cos 120? Cos 120 is cos 90 plus 30, right? We can split it up like this, 90 plus 30. And then we'll use cos a plus b formula, right? We'll use cos a plus b formula, cos 90 cos 30 minus sin 90 sin 30, right? Now cos 90 is 0, cos 30 is root 3 by 2, sin 90 is 1 and sin 30 is half. So you'll get cos 120 is minus half, cos 120 is minus half. Now you substitute minus half for 120, 2 and 2 will get cancelled. You're left with minus cos a plus cos a. Minus cos a plus cos a is 0, which is equal to RHS. Now this is one method of solving. The other method is using transformation formulae. So if you see here, this is of the form cos a plus b and cos a minus b. cos A plus B and cos A minus B, right? This is in the first set of transformation formulae. Let's see that. So here's the list of first set of transformation formulae. Sin A plus B plus sin A minus B, right? Sin A plus B minus sin A minus B. Now we have a problem where we have cos A plus B and cos A minus B. What is cos A plus B plus cos A minus B? It is cos A into cos B. Now let's use this particular formula. So half into cos A plus B plus cos A minus B is cos A cos B. What we will do, cos 120 minus A plus cos 120 plus A is, we'll put this to this side, we shift to this side, so it will become 2 cos A cos B. So 2 cos 120 into cos A. So this is A, this is B, this is A, and this is B. So 2 cos 120 into cos A. Cos 120 is minus half. So 2 and 2 will get cancelled. You're left with minus 1 into cos A, which is minus cos A. And we have cos A here already. So cos A minus cos A is going to be 0, which is equal to RHS. So we've used two methods to solve this problem. One is using transformation formula and the other one is using compound angle formula. Now let's go to sixth problem where we have to prove that sin 65 plus cos 65 is root 2 cos 20. So you can write sin 65 as 45 plus 20. We'll have to use known angles. What are the known angles? 30, 60, 90, 45 and 0. These are the known angles. Using these angles, we will have to split it up. We'll have to split 65. 65 can be written as 45 plus 20, right? 45 plus 20 because we know the value of 45. We don't know the value of 65. So sin 45 plus 20. Similarly, cos 65 also we'll write it as cos 45 plus 20. Now we'll use the compound angle formula. Sin 45 plus 20 is nothing but sin A plus B. Sin A plus B is sin A cos B plus cos A sin B, right? And here we'll have to use cos A plus B formula. That is cos A cos B minus sin A sin B. You can use this formula. Sin 45 is 1 by root 2 and cos 45 also is 1 by root 2. So you'll substitute cos 45, sin 45 values. You'll leave cos 20 and sin 20 as these, right? You'll see that this particular term is getting cancelled with this term. You're left with 1 by root 2 cos 20 plus 1 by root 2 cos 20, which is nothing but 2 into 1 by root 2 cos 20 because this is happening 2 times. So 2 into 1 by root 2 cos 20. 2 is nothing but 2 is equal to root 2 into root 2, right? 2 is equal to root 2 into root 2. You can write this as root 2 into root 2 and 1 root 2 and 1 root 2 will get cancelled. So you're left with root 2 cos 20, root 2 cos 20, which is equal to RHS. So with this, we've come to the end of this particular topic. Thanks for watching. Hope this video was useful.